We're looking at factoring trinomials when you have a coefficient of 1. Now, we have the method of factoring by grouping. I'll start by showing that, and then we can also start to find patterns that happen when there's only a coefficient of 1 that does allow us to factor this easier. So the go-to is going to be factor by grouping unless you see the pattern. So what we did when we had a coefficient that wasn't 1, we would multiply the first and last term. So in this case, we multiply and get negative 24, and we're looking to add to negative 2. Two numbers that do that. Well, 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6. Because it's a negative 24, I want one of them to be negative, and I want them to be 2 apart. So these two, 4 and 6, would work, but I'm going to make the 6 negative. So I would then split the negative 2x to 2 terms, the negative 6x and the 4x, to now give me 4 terms total. Now I'm going to factor by grouping here. I could take an x out of the first 2 terms, leaves me with x minus 6, and I could take a 4 out of the next 2 terms, leaves me with x minus 6. They both have x minus 6, so I factor that out, and I'm left with x plus 4. Let's do that again. X squared plus 5x plus 6. 1 times 6, and that adds to 5. Well, 6 is 2 times 3. That adds to 5. So we're going to go x squared plus 2x plus 3x plus 6. And the first two I can factor out an x. It leaves me with x plus 2. And the next two I can factor out a 3. It leaves me with x plus 2. X plus 2 is the common factor. I factor that out, and I'm left with x plus 3. Now, let's look at what we did. Started here, ended here. Notice how the two numbers that we chose, negative 6 and 4, became the numbers at the end. Same here. 2 and 3 became the numbers at the end. Now this is different than the other section when we were factoring prior, which I actually have the page right here. So from that section, for this problem example, 3 times 32 gave us 96. We got 20. This it adds, and then we did 12 and 8. Now 12 and 8 did not end up being the values right here. We did multiplies to 36, adds to 20. 18 and 2 did not end up being the values here. Now that didn't happen when you have a coefficient out front. But we did do this one problem here where you had w squared minus 8w minus 9. And negative 9 and 1 became the two values that we had. And the difference was we did factor out a 3, but it had a coefficient of 1. And that's the pattern that happens here. The two values that work are the values you're going to use. And part of the reason that happens for us here is this is not a coefficient that we're multiplying. It's a 1. So it's really negative 24. So what we can do whenever we have a trinomial with a coefficient of 1, it has to be a 1 here. This is the number for the sum. This is the number for the product. And then that leaves you to the two values that are going to be the factors. So let's see what that looks like. X squared plus 5xy minus 14y squared. We'll do the quick version and then we'll do the long version just to make sure it still works. So over here we'll do the quick version. So I have negative 14 and 5. So multiply, add. Negative 14, I'm thinking 7 and 2 are a good choice. I want to make the 2 negative because 7 minus 2 is 5, but they do multiply to a negative 14. So we're guessing here that x is the lead term. We don't have any coefficients on it. And then 7 and negative 2 are what we're going to use. Now this one's a little bit different because it has a y squared. Let's just put the y at the end. So x plus 7y and x minus 2y. Well, let's see if that works. Now we're still going to use the same values here, but now we split it. So that's 7xy minus 2xy minus 14y squared. First two terms I can factor out an x, leaves me with x plus 7y. The last two terms, I'm going to take out a negative 2y. That leaves me with x plus 7y. X plus 7y is the same term. Factored out. X minus 2y is our factor. And look, they match. Now, Factor by grouping is the go-to method if this doesn't work for you. But if you see this, use it. It's faster. It'll help you get your answers easier. Now you're looking at the next one going, well, I thought we didn't have a coefficient. But really, this sound has a GCF. So I can actually factor out a 2 from all these terms. We need to fix this, though. We need to make that just a y. So I factor out a 2, and I got x to the 4th plus 8x squared y plus 15y squared. So now we're looking at multiplying to 15, because it's 1 times 15, and add to 8. Well, if I look kind of over on the side here, 15 and 8, I'm thinking 3 and 5. So probably x, I got positive 3 and positive 5. This was x to the 4th. So if I take the square root of that, or how would I get x to the 4th, it would probably be x squared, and then y squared, I'm going to put a y there and a y there. So let's see if we get that same answer. So we're still going to use 5 and 3 to split. So we have x to the 4th plus 5x squared y plus 3x squared y plus 15y squared. The first two terms I can take out an x squared, and it leaves me with x squared plus 5y. The next two I can take out a 3y, and it leaves me with x squared plus 5y. They match, so we got x squared plus 5y and x squared, after we factor, plus 3y. Bring down the 2, and these are our factors. Now we have some easier ones, so we'll kind of go the faster method. So x squared plus 16x plus 63. We're going to multiply to 63. That adds to 16. Now the factors I know of 63 are 9 and 7. 9 and 7 would work. So we get x plus 9, x plus 7. Next we have multiply to 27. That adds to negative 12. Now 27, I can do 9 and 3, but I need negative 12, and that's positive 12, so that probably means they're both negative. So we're going to go x squared, or x minus 9, and x minus 3. X squared plus 2x minus 63. Multiply to negative 63. That adds to 2. Kind of looks a lot like this one up here, but now it's a negative. So with 9 and 7, I probably want the 7 to be negative, because these are going to add to be positive 2, but multiply to be a negative. X plus 9, x minus 7. Next we have multiplies to negative 96. That adds to 4. Now 96, we could do 1 and 96. That's nowhere close. 2 and 48. 4 and 24. 8 and 12. 16 and 6. And what I'm doing here, if you can't see, is I'm doubling these numbers and taking half of those. So it's almost like I'm taking a 2 out of the 48, moving it over to the 4 to get 24. And that's a quick way you could always go through. We could even then go 32 and 3. Quick way to get factors when you're looking at 2's. So from here, it's negative, so 1 positive, 1 negative. I want them to be 4 apart. So I like 8 and 12. And let's make 8 negative, because that way these combine to be a positive 4. So I have x and x. It's going to be x minus 8, x plus 12, but I got this y squared, so I'm going to put it on both of those. Now, on some of these, I'm getting the answers very quick, but you always have the process built in to check your answer. 8 minus 8y, or x minus 8y, x plus 12y. I set up that area model box method, and I can go in and check to make sure I'm getting the right answer. So when I put this back together, I get x squared plus 4xy minus 96y squared, and it does match my original answer. So I encourage you sometimes, if you're a little unsure about the values or how this pattern works, to go back, multiply, and make sure you get back to your original answer. Next here we have multiplies to 42. That adds to negative 13. Well, 42 is 6 and 7. If they're both negative, they'll add to negative 13. And there'll be a positive product. So we'll take those. We're going to go g minus 6 and g minus 7, but since there's an h squared there, I put an h on both of them. Last one, y to the 4th plus 9y squared plus 20 multiplies to 20. That adds to 9. 5 and 4 look like a good choice. Now this is y to the 4th, so when I split it, I probably want y squared, because it's the square root of them. And then we're going to go y squared plus 5, y squared plus 4 as our factors.